like got out of the screen. That's like. All right, we are YouTube live streaming now.
When did you want to start lunch?
I think he left. I think you can start.
Yeah, you can start whenever.
Okay, cool. Yes, welcome to Introduction to Databases. Today we're going to be fixing a fast and light autonomous mega spaceship. So to get started, you're going to learn SQLite to query structured databases, MongoDB's document-based databases to get some more flexibility, and Neo4j's graph-based databases to get some insights into the relationships in your data. And just for some context, you're the sole programmer on call for the first flight of the SS2D, a fully autonomous fast and light mega spaceship. That's you. And suddenly your Motorola long-range pager flashes. All software on board the SS2D has been deleted. If the SS2D continues on its current heading, it's going to crash into the sun, creating a permanent night. So we're going to have to fix that. A quick briefing on the systems. The SS2D has 3 central databases that you're going to need to write code to fix. First one is the navigational database in SQLite. The systems data is stored in MongoDB. And we have crew management data in Neo4j. So to get set up, go to tweedydb.com and you'll get access to the ship systems. And I guess just send done in chat whenever you've got that set up. And I can't see chat, so someone let me know when we've got a lot of dones.
Do we have to just click it or like enter our information as well?
Just open it up right now. And then your Zoom name. So you can do first and last name for your name there. And then password is Galactic Frog. Capital G, capital F, space in between. You'll see something like that. It's the first problem. We'll get to that later. I'm not just going to throw you in. Is that working for everyone? The password works? Okay, cool. I'm seeing a lot of dots. So you can just put this tab to the side, but for now, we'll get to the practice problems later. Part 1, we'll go over SQLite. So why SQL, first of all? It's widespread and standardized. So it was invented in the 70s. And it's kind of designed for like any business major would be able to read it and make sure that us programmers are not stealing money. So it reads like English. It'll be really easy to pick up quick. And SQLite in particular, because it's simple, self-contained, and serverless. So it all is contained in one .c file. So if you're on mobile, if you're on web like we're doing right now, on the client side or embedded projects, SQLite works great. If you only take one thing away from this part, remember just how to select rows and columns from a table. Don't worry about anything fancy like filtering or ordering. Just find a table and get the rows and columns from it. So SQLite, everything is stored in tables. So here we have a mascot accounts table. So this is the bank account of a bunch of hackathon mascots. We see we have columns like name, email, balance, and then each row would be one mascot. So we have mascot Bob with Bob at vhx.ca, and Bob's kind of rich. So whenever we want to get data, we have to tell SQLite what columns we want. So maybe we don't care about email, we're just sending bills. We don't want to send marketing emails. So we're going to get the name and the balance. We have to tell SQLite where to get this data from. So we're saying we want it from the mascot accounts table. And then we can filter. So maybe we only want to send a bill to people with a balance greater than 0. So we'd filter, tell SQLite that condition. So we'd go through Bob, you have balance greater than 0. Ari has a balance greater than 0. And Curly has a balance greater than 0. So in SQL, it looks a lot like the English that we just went over. We'll select name, comma, balance, these 2 columns. from the mascot accounts table where balance is greater than 0. And we get these results back: the name column, the balance column, and then the rows that we selected. If there are any questions, please put them in chat. If this isn't making sense, I can try to explain a little bit better. Or unmute because I can actually see chat. So we can also include multiple conditions with and or. For example, we'll select the same columns, name and balance. Tell SQLite where we want to get the data from, so mascot accounts. And we'll filter where balance is greater than 0, like last time, or name equals echo. So maybe echo is special and echo always gets billed, even though echo has a negative bank account. And just like last time, we get the name and balance columns and all of the rows that matched our where clause here. So to review, basic SQL statements always look like select something from some other table with some fancy stuff added, such as a where clause to filter which rows we want to actually pull from the database. Inside the where clause, we can have comparison. So last time we had equal signs. We can also have not equals, greater than, less than, and logically combine different expressions. So and or not. So this makes sense to everyone so far? Any questions in chat? Cool. So getting a little bit more advanced, we can sort our results with order by. So just like last time, we'll select name and balance from our mascot accounts table. And this gives us something in a completely random order. SQLite doesn't care how it's ordered. It's not going to bother ordering it if you didn't tell it to. So Bob could be down here. We don't really know how it's going to decide to order things. If we say order by name after from, it's going to rearrange everything in alphabetical order by name. So we could also order by balance, and it would start 0 at the top, and then, I guess, negative 892 at the top, and then ascending order. We can put descending after it, DESC, and it'll sort the opposite direction. And then one more thing to be a little bit more fancier, we can use a limit clause after order, and that's going to limit it to just the top result. So here Ari comes first in the alphabet, so we only get one result back. This is really useful if we sorted by balance and we limited one, we'd get either the lowest balance or the biggest balance. And it's also good when you have like a million rows and you don't want to blow up your machine. So you could say, just give me the top 10. I don't care about all of them. And to review again, we've looked at 5 clauses so far. We select some values or some columns from a table, so where we actually want to go and get that data, where, and we're going to filter the rows that we want to select, order by some condition to sort it, and then limit 1 or some other number. And they will always go in this order. We'll be adding one more later, and I'll have a fun acronym to remember. Does that make sense to everyone so far? Yeah, so it's kind of like English, right? We can do statistics with aggregate functions like sum and average. So here, if we want to get the average balance of all of our mascots, and they'll sum the balance, so we'll get how much money we have total in the bank, and then the count, how many accounts do we actually have. We'll average the column that we want to average, get the sum of the column that we want to average, and when we're counting, it doesn't really matter which column you count, so we'll just put 1 in there. And again, we have to say from mascot accounts, what table do we actually want to get those columns from? And we get a result that looks like this. So each column is the aggregate function that we used here. So this might be a little bit less clear than we had before. So let me know if there's any questions. We can also aggregate using group by. So for instance, if we wanted to get the average amount of money in a bank account for each hackathon, so maybe the V8 hacks mascots here, we want to see the average in that account, the average for all the Freetail mascots, and the average for the HackTams mascot, which is all alone. We would select the hackathon, so this column, and the average balance. So we're averaging the balance here from mascot accounts. This time we're grouping by hackathon. So it's going to take the VH hacks, group them together, Freetail, group them together, and the HackTams mascot and group that together. And for each group, it'll average that balance column like we ask it to here, and it's going to return the hackathon and the average balance for each group. Does that make sense? No questions? Cool. I'd also like to point out that the duck here from HackTams, I don't remember when I was writing the slides. It does have a better name. It's actually Quackhead. Anyway, we've covered 6 clauses so far. We have select something from some table, where some condition, group by a column. So like if we want to group by the hackathon to get the average for each hackathon, order by something that we want to sort with, and limit 1, 10, whatever number that you want to limit the number of rows to. They'll always go in this order. So you can think of it as stinky feet won't grow old, longevity. But eventually this just becomes like a second language. You're not going to forget what order they go in once you've done enough practice problems. And if you only take away one thing from this part, just remember how to select rows and columns from a table. That should be enough for most projects. So select the columns that we want, name and balance, from whatever table we want, mascot accounts. Any questions? So I have some Tweety stickers that I printed out. So if you ask any questions, I get one of those sent to you. Tweety was the cute airplane at the beginning, by the way. Nothing? Okay. So open up tweetydb.com again. You should have already put in your name and the password Galactic Frog, but if you're just joining, this is where we're going to be doing practice problems. So that will be your login info. And then start fixing the SS Tweety. So please ask in chat or ask a mentor if you have any questions. Offer still stands for the stickers. And I think there'll be about 6 problems before we move on to the next section. I'm going to turn my camera and mic off while y'all are fixing the problems, but I'll be on chat. Looks like a few people are stuck on question number 2. Make sure instead of commas in your word clause, you have and. That's a mistake that I make all the time as well. So instead of saying azimuth equals some number, comma, zenith equals some number, replace the comma with ands. And for question number 4, I think, make sure when you do sum, you have parentheses after sum. So it's sum parentheses and then the column that you want to sum inside the parentheses. Okay. Am I sharing the right scene or screen? Can everyone see part 2 MongoDB? Cool. Looks like most people are finishing up. So if you want to come back to the slides, we can start on part 2. If you didn't quite finish, we can come back to it later in a VC or something and go over the problems. How's everyone feeling about SQL? Okay, hopefully good. So part 2, we're going to look at MongoDB. So this time, stepping away from English. This one's a little bit more cryptic. Might be harder to wrap your brain around, but you'll get it. Why MongoDB? And I think the primary reason would be flexibility. So we don't really have tables with columns in MongoDB. All of your rows can have whatever columns you want. They don't all have to be the same rows or the same columns, which has its advantages if you have like multiple departments that maybe want to use the same application, but they have different data formatting requirements. If you only take one thing from this part, Mongo keeps flexible documents in collections. So we don't have rows and tables anymore. We have documents, which are rows, entities, things with the data inside of them, and collections, which is just a bunch of documents. Yeah, so you can think of it like a file cabinet. We just have a bunch of things in there. They're not necessarily the exact same structure, and you just throw them in. We're not keeping nice tables anymore. So for example, we could have an employees collection and a schools collection, and they don't necessarily have to be the same type of data inside. If you've seen JSON before, this probably looks familiar. Mongo runs on almost JSON, it's binary JSON. Anyway, so if we wanted to select data, we would tell Mongo which collection to go to, so basically which filing cabinet to go to. We'll tell it which fields to filter by. So this time filtering goes before we select columns. So this is like your where clause. You say we want the mascot to be Bevo. And that's pretty much all we have to do. It'll give us the relevant documents back based on that filter that we sorted by, or that we filtered by. So in Mongo, instead of English, we say we want the database.schools. So all of this would be the database, both of these collections here, and the schools collection is the one that we want to look at. We'll do .find. So this is kind of like your select and your where clause in SQL. So we want to find the documents having mascot equal to Bevo. So these are kind of the same format here. You'll have your curly braces, the column that you want to look at, colon, and the value that you want it to equal. And then you'll do .exec. That part's kind of depends on which MongoDB client you're using. But in this workshop, we'll pretend we have to do .exec every time. That'll get us back that one document that matches our mascot Bevo. And if you left the curly braces blank, it would get every document, just like leaving off of where clause in an SQL statement. Does that make sense to everyone? A little bit more cryptic than SQL, but hopefully you can understand and parse that. When we get to complex filtering, though, it looks even weirder. I'm not a big fan of it, but it is popular in the industry. So just like last time, we'll go to the schools collection by saying we want the database.schools. We'll do .find like last time with your curly braces. And let's say we want latitude is less than 40. We can't just do like a less than sign. We do latitude, so the column that we want, colon, and then another set of curly braces, $LT for less than. So it's less than 40. So it looks really weird, not intuitive at all, but it's what we have to do. And then we call that .exec, and it'll get us our document back where the latitude is less than 40. But it gets even weirder than that. So we can use an or. Instead of having just or between two pieces of the query, we use $or, colon, and then square brackets. So it's like a JavaScript array, if you've ever worked with JavaScript. And inside the square brackets, we have a bunch of, this is actually incorrect, isn't it? Pretend that these are in curly braces here. So we'd have curly braces, latitude, colon, less than 40, end curly braces over here, then comma. Then you'd start another set of curly braces. Longitude is greater than or equal to, that's what the $GTE means, 97, and then an extra set of closing curly braces here. So every comma separated thing inside of the or could be put inside of the .find by itself. And you're just kind of running the query twice. Not exactly how it works in the real world, but you can think of it as running .find twice and then combining those two results together. Yeah, and I apologize for the syntax errors there. We'll do .exec, and it will find things where either the latitude is less than 40 or the longitude is greater than or equal to 97. And you have $ and, not, less than or equal to, greater than, not equals. Those are just things that you have to remember. And yeah, that's kind of gross. So make sure you're texting in chat if you have some issues come up with the queries in the next set of practice problems. But if you only take away one thing, just remember that the reason we use Mongo is because it's more flexible. And we're keeping the flexible documents inside of collections. And that would probably be enough to pass any interview. So you can open up 2ddb.com again. If you accidentally close the tab, just put your name as the name on Zoom, and then you can set the password to Galactic Frog skip SQL, and it'll take you right to the Mongo problems. And keep fixing the SS treaty. This one's a little more confusing, so please be active in chat if you're having any issues. So there's a question about filtering. It will be curly braces inside of the dot find, and you'll have the column that you want to filter with, or the field or property or whatever Mongo calls it, then a colon and the value that you want it to equal. If you don't want to filter by anything, you would do dot find and just leave the curly braces blank. Another question, chat. So the first Mongo question, whenever you're selecting a collection, make sure you do db.systems to get the collection that you want, and then dot find with your empty curly braces. Let me know if that answers your question.
Hey guys, I just want to remind you to fill out the sign-in form if you haven't already. I put the link in the chat and the secret code should be TOAD. Just make sure you fill that up before the end of the workshop. Thanks.
How's everyone doing so far? Please use chat if you're stuck. We've got really good mentors in here, so they'll be able to help you out. So on the one where you have to use or inside the query, make sure you don't do what I did and add curly braces around each element inside of the or. So it'd be square brackets, then your curly braces, write your normal filter in there, closing curly brace, comma, in the next filter. And send me a chat if you're still struggling with that one. Okay, so we're at 3:45 now, so we can come back to the slides. I think most people got done or almost done. So yeah, Mongo is a little bit trickier, less intuitive than SQL is. But I think just going through some of those practice problems, that would be enough to get a job easy. So if you want to come back to the slides, we're going to be going over Neo4j. Can you all see part 3, Neo4j? I assume y'all can. I'm not seeing any chats to say otherwise. So Neo4j is a graph-based database. It's very different from Mongo and SQL. So we don't just store data, we also store relationships between the data. So like in SQL, if you wanted to store relationships between like a person and a school, so you want to say this person attends this school, you have to get into like primary keys, foreign keys, and you might have to create a separate table to store all of those, and your relationships become entities, and it's just a mess. So with Neo4j, relationships just become another part of the data. It's much more natural. And with those relationships, you can usually find more insight in the data, which means more money for businesses. So yeah, it's graph-based, which means we have nodes and edges. Nodes are just things, and edges are the relationships between those things. If you take one thing away from this part, Neo4j stores things and relationships. The relationships is the important part there. So if we just had things, so if we had a bunch of hackathons and schools and people up here, you don't get very much insight into this data, right? So this is what SQL would give you. It's just kind of confusing, we don't understand it. But when we add the relationships in, we can see Ryan organizes Hack Texas organized at UT, and UT is a rival of A&M and located in Texas. You get a lot more information about this data. So Neo4j, if we wanted to list all of the organizers, I'll just walk through it in English first. We'd start by selecting people. And then you'd get all of the people that have an organizer's edge or organizes. So this is a relationship. Ryan's going to organize something. We don't really know what yet. We say organizes an event, and I'll get that next node. So we would know that Ryan is a person who is an organizer. So Neo4j, we would say match. And match is kind of like our select in SQL. We want a person. So that's what our label is here. So you have a key and then a colon and then a label. So our key is P. We want a person, we'll call that person P. We want a person who organizes. So we're kind of starting to draw an arrow here. The first part of the arrow, organizes, is the name of that relationship. And then we finish the arrow with an event. So event, the label is event, and the key is E. So labels would be like a table. All of the events have a label event. You see it draws an arrow from this side going to that side, and the middle of it is like a label for the arrow organizes. And at the very end, we'll say return P, comma, E. So returning that person that we matched here and the event that we matched here. And we should get back Brian and Hack Texas. Send chat if that doesn't make sense. It's a little bit more Englishy than Mongo is, but it can still be hard to visualize and understand since we're so used to tables and SQL. We can get a little bit more complex, and it doesn't really change the complexity of the query. The queries still stay really simple. So if we want a list of the people who have attended an event that Ryan organized, a bit of a mouthful, we would select Ryan, find the organized edges, just like last time, find all of the events connected to any of the organized edges, find the attends edges, and then find the people connected to the attends edge. So we're looking for the relationship Ryan organizes something, and then find the second relationship attends. So find anyone that attends Hack Texas. And in Neo4j, it would look something like this. So you'd want to find a person. We'd filter a little bit more. So this is actually just like MongoDB's filtering. None of the practice problems have this though, so don't worry about it. We just want to find someone with the name Ryan. We're starting our arrow for organizes. And we want an person who organizes an event. You notice we don't have the key here. We don't want to return Ryan because we already know who Ryan is. We'll find another relationship attached to that event. This time the arrow is going the other direction. The arrow is kind of split out to two lines, but we have a person, and this time we do have a key P. So that person attends the event that Ryan organizes. And we're going to return P. So that's the only one we actually gave a key to. The syntax here is a little bit off. We should actually have colons in front of these. Don't worry about that. It's not going to mess you up on any of the practice problems. And that P is going to return Tammy. So when a person connected to an event by some attends relationship, and that event should be connected to Ryan by an organizes relationship. Hopefully that's not too confusing. We have 3 practice problems in this one, so not as much as the last ones. But if you take one thing, Neo4j is going to store things and relationships. And the key is the relationships. That's where you get all of the insight from your data. So we'll go back and finish fixing the SS Tweety. This time you can put your name, it's the name on Zoom, and password Galactic Frogs, get Mongo if you close the tab. And ask questions, please, because this one's, it reads like English, but the model of the data is kind of less intuitive. I'm seeing the first few queries come in. Remember that whenever you're matching something, your node is going to be in parentheses. So it'll be parentheses P colon person for your key colon label, and then close parentheses. The relationships will be in square brackets. And that's the entire node, or the entire thing should be in parentheses. So open parentheses before the key. I can type an example in chat real quick.
I have a question. I guess more of like a less of a syntax question, more of a I guess logistics question. When would y'all use each of these 3 different types of databases?
So SQL probably at older companies. It's just kind of the standard, so it would be my default. Mongo is one times I've actually used it at a business, and it was where we had 3 different departments using the application that we built, and all 3 of them had different data that they wanted to store. So using Mongo, we could give each different department a different fields inside of their collection, inside of the documents. And that way we could use the exact same application for all 3 of them. So in SQL table, you couldn't do that because the columns are set in stone. The Neo4j, probably like social media stuff. So I could see Facebook using it to keep track of all the people, events, and matching up who follows who. Probably some fancier stuff like how well you know someone. Like if you're doing machine learning based on that, it might be based on Neo4j.
Cool.
Does that answer your question? Make sense?
Yeah. Have you ever used one of these in like a hackathon or something before for like a small project or something?
Yeah, I usually use Mongo for hackathons, even though it's kind of awful. It's more popular at hackathons, it seems like. They also sponsor a lot of events.
Cool. All right, we have about 2 minutes left until the next workshop starts. Did y'all have anyone else have any last questions? Okay, cool. Thank you so much, mentors and workshop leaders. I personally learned a lot about databases.
I've got one last slide with contact info on it if anyone wants to reach out with more questions, and also the real life Tweety and Bluebird. Yeah, ping me on Discord or send me an email.